Okay, I think I can start now, guys. So let me first, before I start what I want to teach today, let me first make a quick revision on what I did in this chapter. Okay, what is the purpose of this chapter? Okay, so in this chapter, um, I'm explaining what we call interrupts. Okay, and what I said, how interrupts is gonna make our program different from what we did in chapter 3. Okay, what's gonna be different is in chapter 3 what we did in chapter 3, I'm gonna call it main program. Okay, so this is the main program. This is everything you did in chapter 3. Your program was only in one place, including subroutines. So here also including subroutines. So all your program was in one place. That's what we call main program. Okay. Now your program is going to be in different places. For example, I can use IRQ. Okay. So I'm going to put a piece of code here. I'm going to use RTI. So I'm going to put a piece of code here. Or maybe I'm going to use different interrupts because we have different types of interrupts. Okay. And then what happens is when IRQ is triggered, it's going to leave the main program and then come back to here. Okay. And come, if there is the interrupt here, go here, go to RTI and come and so on. Okay. Why this idea is fantastic? Why it is a great idea? It is a great idea mainly because now I can make big programs. Very simple, very small sentence, very important sentence. We can make big programs. Okay. Why you can make programs? Because now my program can have different tasks. So here in the main program, I can put one task 1. I can put here in IRQ, I can put task 2. In RTI, I can put task 3 and so on. By this way, I can make big program, okay? And that's what we are gonna see right now. Today, or even in this chapter, most of the things, in this chapter, the programs of this chapter, I already explained to them in chapter 3. But in chapter 3, I put this program in the main program, main program. Now I am moving these tasks to other IRQ, to interrupts, so that I leave the main program empty, so that I can put another task there. Is that clear, guys? Any question? This is the main idea. Any question? Okay. Also, what I explained is it's very simple. Interrupt is like calling a subroutine. Exactly same thing. You leave the program, execute some code, and come back. It's exactly like calling a subroutine, but there is a small important difference. The small important difference is when you call a subroutine, you have to write instruction branch subroutine or jump subroutine as we did before. Okay, but here in interrupts, I'm not gonna write instruction to call a subroutine. Okay, subroutine is gonna be called automatically when event happens. And this event has to come from hardware, from somewhere hardware. And that's exactly what I explained. For IRQ, we have one pin here. Every time there is a falling edge, okay, or low level, you can select one of them, okay. This is actually the event. Every time there is a falling edge or low level, you can trigger interrupt. That means a subroutine is going to be executed. Every time there is a falling edge, a subroutine can be executed, okay. Someone can ask me where this falling edge is going to come from. Okay, it can come from a switch, as I explained last time, and also as I explain, as we are going to do today in the lab today, it can come from a switch, so that every time I press from push button, sorry, every time I press the push button, you actually trigger interrupt. This is one way to do it. Another way, it may come from a sensor here. This sensor is sensing something, and when there is someone is cutting the light here, infrared light, or there is a fire alarm or whatever, there will be like a falling edge here. Okay. Another important thing I told you about, guys, is here I can use IRQ actually for frequency meter to measure frequency. How can you do that? Simply, the idea is this is a signal I want to measure the frequency. Okay, I am sure every time there is a falling edge, every time there is a falling edge, you actually is going to trigger interrupts. This is one interrupt, interrupt here, interrupt here, interrupt here. All what I have to do to measure frequency is I need to count how many interrupts happened in 1 second. So I'm going to enable IRQ for 1 second. Okay, and inside IRQ interrupt, I'm going to say increment counter. So every time it is interrupted, I'm going to increment the counter. I need to know how many falling edge are in 1 second, because every falling edge is going to be 1 cycle. And this is the definition of frequency. The definition of frequency is how many cycles in 1 second. One more thing, another application for this, guys, is, you know, there is something called we can measure motor speed. Motor speed. I'm going to tell you what is the idea of measuring motor speed. The idea is that you can have here like infrared light and receiver. So this is like one package. One package is this way. Okay. So here, this is infrared transmitter, and this one is receiver. Okay. And the idea is that when there is no object here, and when the light hits the receiver, I'm gonna get 5 volt. This is the main idea. Okay. And then if you put some object here and there is no light hitting the receiver, you are gonna get 0 volt. Okay. And then the idea, I can bring a disc, and in this disc I can put 2 holes this way, and I can connect this disc to a motor, the motor shaft. Okay, and this disc has to rotate here. This disc has to rotate here. Okay, you know how the signal here is gonna look like. It's gonna be high, and when it it's gonna be low. It's gonna be low. Okay, and when the hole comes, it's gonna be high. Okay, and then after this is the hole, and then it's gonna be low again, and this is another hole, and so on. Okay, so every complete rotation, I should have 2 holes. 2 pulses this way. This is a complete rotation. Is that okay? By the way, it's the same thing, but sometimes it's the other way. Sometimes it is high if there is no light. If there is light, it's gonna be low. It's okay. It's almost the same thing. Okay, so it depends on the kind of the sensor you have. It's not a big deal. Okay, so what we can learn here is I need to count. To measure the motor speed, I need to count how many rotation in 1 minute, or how many rotation in 1 second, and so on. Okay, so in order to count the rotation, it's exactly the same idea I explained here, or very close idea. I need to know how many falling edge. I need to know how many falling edge here, because, and then I have to divide it by 2. Because why you have to divide by 2? Because every two falling edge, it means 1 rotation, 1 complete rotation. You got what I'm saying? By this way, I can measure the motor speed using IRQ as well. I'm just giving you another idea. Any questions? Question, guys? Okay. This is one interrupt I explained last time, and I'm gonna continue today. By the way, I already finished IRQ and RTI. What I'm gonna do today, just the programs. So that is what is left in chapter 4. I'm going to teach some programs so that you can better understand RTI and IRQ. Okay. The other thing here is RTI. Also, I explained it last time. Different from IRQ, RTI does not have external pin. So this is a microcontroller. There is no external pin. This is different from IRQ. Okay. Okay. What is this? It is a timer. So there is a timer connected to the microprocessor. Is that okay? And then what happens is that once you set the timer, so it is a timer, you can ask the timer, please interrupt every 131 milliseconds. Okay, and this timer is connected to the microprocessor, and this is internally inside the microcontroller. What happens? This timer is gonna trigger interrupt. It's gonna like generate a pulse every 131 millisecond, so that you can trigger interrupt from microcontroller every 131 millisecond. Which means this is for programming. This is the most important thing. That means we have a subroutine, okay, RTI subroutine. This subroutine, I'm quite sure this subroutine can be called automatically every 131 milliseconds. So you can write whatever. That's what I guarantee. Once you set the interrupt, RTI interrupt, okay. So I have a subroutine. This subroutine is executed every 131 milliseconds. Any question, guys? So this is just a very quick revision on what I did in this chapter before I give you, I teach the new programs. Any questions? Okay. It's very easy. Yeah, last time I taught this program, and this is what you have to do in the coming lab anyway. You have to modify this one in this lab, today's lab. Okay, here you have a flashing LED, and the flashing is done by RTI. So the code to do flashing is done by RTI. Okay, that's what I explained last time. And IRQ is connected to a switch. Okay, so that I can turn the flashing on and off. How can you turn the flashing on and off? As I said, what I have to do is that if flashing is off, okay, I'm gonna enable RTI to make it on, right? Because again, the code that make flashing is in RTI. If RTI is disabled, that means there is no flashing, right? Because the flashing is done by RTI. Okay, so that's exactly what we did. So we used IRQ to enable or disable RTI interrupts. If RTI is enabled, I'm gonna make it disabled when you press the button. Okay. Also, if it is disabled, you enable it so that this way you can make flashing on and off. Okay. And again, so now I put one task in RTI, which is flashing. I put one task in IRQ, which is you turn enable or disable flashing. The main program is empty. You can put something in the main program. Okay, that's what I want to say. That's the beauty of, or that is the importance of RTI, of interrupts. Okay, maybe I am going to show a video for this one. So here, flashing LED on and off. I'm going to show the video now. So you can see the LED was flashing. When I pressed the button, it's not flashing. When I press the button again, I make it flashing and so on. This is the wire I used here. I told you need to connect a wire between the push button, whatever you use. You have 4 of them. You can use one of them, one PH. Okay, pitch 0 to pitch 3. You have to use one of them, and you have to connect it to second pin here, which is the IRQ. Okay. When I film it, when I recorded this video, I was in home. I didn't have a good wire, so I just have. It's not very nice wire, but it worked, and just what I had in my home. Okay. Okay, so now the program, this is what I did last time, guys. What I'm gonna do today, I am not gonna teach any new stuff in chapter 4 anymore. All what I'm gonna do, guys, now, just the programs to better understand how can use interrupts. That's it, okay? So what I'm gonna do now, I'm gonna do time multiplexing. You remember in chapter 3, we displayed a number like 3, 4, 5, 6, okay? Time multiplexing, okay? And we did this time in chapter 3, we did this time multiplexing. I put it in the main program. Now I wanna move it to RTI, okay? I'm gonna move it to RTI so that the main program is free now. I can put something else, okay? For sure, you have to be you have to be smart. For sure, when I cannot move time multiplexing to IRQ. I cannot, right? Because time multiplexing needs frequent interrupts. You understand what I'm saying, guys? It needs a frequent interrupt. So in one interrupt, I'm going to display number 3. Next interrupt, I'm going to display 4. Next interrupt, I'm going to display 5. Next interrupt, I'm going to display 6. Next interrupt, I'm gonna go again to 3. You got what I'm saying? That's what we did in the main program, but I'm gonna move it to interrupts. So every interrupt, I'm gonna display one digit, right? Next interrupt, next digit. Next interrupt, next digit, and so on. That's what we're gonna do. Okay? Let me show the video first before I talk about the program. Okay. So you can see here, guys, the number is very stable. There is no flicker, very stable. Okay. Okay, now let's teach the program. I already explained the main idea. The main idea, as I said, every interrupt we have to every interrupt we're gonna display one digit. Okay, guys. So here, guys, this is what we did. Just a quick reminder. That's what we did in chapter. Let me make the color red. So that's what we did in chapter 3, guys. I told you, remember what we did here? We had here one value has to go to port P, another value has to go to port B. Okay. I think this one, yeah, this one has to go to B, and this one has to go to P. This one is to enable one. You remember, to enable one segment, 7 segment, and the other one B. This is the number I'm going to display. Okay. So that's exactly what we're gonna do right now. What I'm gonna do right now, guys, in one interrupt, I'm gonna take these two numbers, one to B and the other one to P. Next interrupt, I'm gonna come here. Next interrupt, I'm gonna come to here. Next interrupt, I'm gonna come to here. Next interrupt, I'm gonna repeat again, go to the beginning again. So every interrupt, I'm gonna take one number. I'm gonna display one number in every interrupt. Okay, guys, any question? Okay. What is really very important now is what is the time out? What should be the time out in this case? Okay, for sure, if you, and I'm quite sure some of you are gonna make this mistake. If the time out is 7F, as we did before, if you put 7F here, 7F is gonna make 130 millisecond or 131 millisecond. Is that okay? That means you are gonna display this one. And then after 130 milli, you are going to display number 3. And then after 131 millisecond, you are going to display 4. And then after 130, I'm going to display 5. And then 6, and so on. For sure, you are going to see flicker. You will see flicker because the time is too much. 131 millisecond is too much. You will see flicker. Okay. So what I did here, I made it 10, number 10. This 10, let me remember. I think, let me go back. Yeah, I think this 10, it's a very small time. I think it's a very small time, like it's less than 1 millisecond anyway. Okay. So anyway, so you already have the table. I explained it last time. So you have to say, that's what I'm saying. You have to select, if you see flicker, that means the time out of the interrupt is very long. Okay. You have to make it shorter. And that's what I did here. Okay. Because I'm saying that because most of the time we use 7F, because most of the time I want to use 131 millisecond. And that's what we are going to do in today's lab, because I want to make flashing every 1 second, 2 seconds, 3 seconds. Okay. But in this case here, time out has to be small value. Small means less than 5 milliseconds, I guess. You can try, but what I'm saying, if you see flicker, this flicker means the time is too long. Okay. So now let's see the program here, guys. So this is the number I'm going to display. This is the number is here, and this is the which 7 segment you are going to enable. Okay, that's what I explained. Okay. Also, I'm going to use here a variable called count. Okay. So count in the beginning, count equals 0. Okay. So 0 plus the beginning address. I'm going to get this one. Okay. Yeah. Sorry. So that's exactly what you are going to see in the code right now. Count in the beginning equals 0. 0 plus the beginning address, I'm going to get this one. Okay. Then I'm going to increment count. Then count plus beginning, I'm going to take this one. Okay. This is one interrupt. Next interrupt, I'm going to repeat the same thing. Now count equal 2. Count plus beginning, I'm here. Okay. Increment count plus beginning, I'm here. Okay. Same thing. Next interrupt, I'm gonna do the same thing. count plus beginning, increment count, count plus beginning. That's exactly what we're going to do right now. And then once I come to here, I have to reset count again so that I come back to here. That's exactly what you see now. Okay, guys? So here, that is why I define a variable here called count. Okay. Now RTI interrupt. How can you? That's what I explained last time. That's what you are going to do. That's what you are going to do today. So how can you configure? How can you program RTI interrupt? This is number one, right? Or this number one. This part is just because I'm using the 7 segment. So this is to program the 7 segment. I explained many times before. And this is here. This is to enable RTI interrupts, guys. And this one, that's what I explained. The time you have to select a small time. Okay. Once I finish this configuration, once I finish number 1 this part and number 2 this part, guys, now RTI is working. Now every very small time, okay, or every periodically you have a subroutine. This subroutine is going to be called. Okay. So this is the subroutine is here, guys. Again, in the main program, someone can ask me, why in the main program you make branch this way? Simply because here in this program, I wanna explain only one task, which is this one. This is the task I want to explain. How can you do time multiplexing using RTI? In reality, when you make big programs, I'm not gonna make a branch this way. Okay, I'm gonna put a task in the main program. Okay, so what happens here? You branch every time out. You are gonna come execute this one, come back, go execute, go, and so on. Okay, so now let's see. That's what I'm saying, guys. We have a subroutine here. I am sure this subroutine is going to be called every very short period of time. Okay, what should I do here in this subroutine? Exactly what I explained here. Okay, look here, guys. Number 1, don't forget this one. Always you have to write this one in order to clear the interrupt flag bit. Okay, always, yes. Okay, also you have to end with RTI, always. Okay, so that I can return it back. Okay, now let's see how it works. That's exactly what I told you, guys. Count plus the beginning is going to give you one value. This value has to go to port B. Then increment count plus beginning. So this one has to go to port P. And that's what I did. Look how I did it, guys, here. Let me just focus on this part. So this is the beginning address here, guys, in X. And now A should equal count. Okay. And now I'm going to take the value pointed by beginning plus X. That's exactly, and it has to go to port P. So this is byte. This byte is pointed by X plus A. And A should have the count, the value of count. And X should have the beginning address of the array. Okay. So now I got the first guy. In every, that's what I told you, guys. In every interrupt, I'm gonna take 2 bytes. 1 byte here from here, 1 byte from here has to go to port B, and another byte from here has to go to port P. Okay. So that's what so now I'm gonna increment the count so that I need to get the second one. And then I repeat it the same again. Just everything again, but this time it has to go to port P. Okay. Until now, and then increment the count for next time. So now count is pointing on the on here, counting in the very beginning. Let me clear this one. In the very beginning, count was here. I incremented, so count is here, and then I incremented, so now count is here for next time. Remember, I told you I'm gonna take 1 record every interrupt, because in every interrupt I'm gonna. So this is 1 interrupt. Next interrupt, and then I have to repeat again. Okay, so you can see here, guys. So I increment count until here I am done. So why you have this part here, guys? Simply because I told you, if count equal 8, it means I'm here. It means I finish this one. Okay, so I have to go reset it again so that I repeat. This is the purpose of this part. Okay, so here I'm gonna compare count to 8. Okay, if it is not equal 8, so I'm done. If not, so I have to clear it again. Any question, guys? I'm done with this program. Any question? Very important thing, guys. Look here. If you go to chapter 3, look at the program I wrote in chapter 3 and compare it with this program. I think you will see this program is much simpler, much simple. Why? Why this program is simpler than the one I taught in chapter 3? Because the difficult part, which is periodic interrupts, it's already done by the hardware, done by RTI. You got what I'm saying? So I don't need to write a code to do like periodic interrupts or something like that. It's already done by the hardware. Okay. Any question? Let's see the next program. In the next program, guys, I want to use RTI to count from 0 to 9. Also, I explained the same program in chapter 3. I'm repeating this program so that I'm going to use it. I'm repeating it so that because I want to move it from the main to the interrupts. Okay. So you are going to count from 0 to 9. And here, I want to count every 1 second. Okay. I'm going to explain now the program. Also, I'm going to show you the video as well. Okay. Also, I'm going to tell you here, I want to use a push button. So this is the main program here. And then I'm going to modify this program now. I'm going to modify it so that I'm going to modify it so that when you press a button, you can turn the counting on and off. Okay. So before I teach it, I want to show you the video first. So again, this one should count from 0 to 9 and then from 9 to 0 back again every 1 second. So this is going to count every 1 second. And then also there is a button. When you press the button, you can stop. Or you can resume counting. I will choose a video before I explain how to do that. This is counting 1/7 segment. Can you see it, guys? It's counting. Can you see it's counting? Now I'm gonna press the button. No counting. After 0, it has to come back to 1 again. Press the button and so on. Okay. Okay. How can we do this? The way we are gonna do it, guys, is we are gonna use RTI to take care of counting. Okay. So RTI should count as I said, every 1 second. Also, IRQ is gonna take care of enabling or disable RTI. You got what I'm saying? So now RTI is gonna display one number every 1 second, right? Counting. And IRQ should enable or disable RTI. Okay, every time I press, if it is enabled, you disable it, okay? And so if disable, you enable it, okay? So this is the main idea. Look at the program here, guys. Number 1, here. This is, okay, let me just change the color to it. Okay, look here. So this is the code I have to use. So this is the code for number 0. This is number 1 for the 7th segment. Number 1, 2, until 9, okay? So the idea is that in one interrupt, I have to output this one to port P in one interrupt, okay? And then after 1 second, I'm gonna take this one. So from here to here should be 1 second. After 1 second, I have to send this one. After 1 second, I have to send this one. After 1 second, I have to send this one. Is that okay? Once I am done here, I have to come back to the beginning again. This is the main idea. So the main idea is that every 1 second, I'm gonna put a different number on port B. Okay. So now 2 questions now. Number 1, the first question is that, as we did last time, how I can count for 1 second, because RTI does not allow me to make interrupts every 1 second. That's what I explained last time. The maximum time out I can get from RTI is 131 milliseconds. That's why last time, and that's what we're going to do in today's lab, you have to count for 8 interrupts. So every 8 interrupts, so here I'm going to output this one. After 8 interrupts, I'm going to output this one. After 8 interrupts, I'm going to output this one. After 8 interrupts, I'm going to output this one, and so on. Is that okay? Because 8 interrupts means 1 second. Okay, that's why, guys, I have a variable here similar to what I did last time to count 8 interrupts. This is number 1. Number 2, okay. No, number 2 also, I'm gonna use a count here, guys, similar to the count I used in the previous program. This count should be, I'm gonna add the beginning plus count. So in order to know which one I have to output, which one. So what I'm saying is that in the very beginning, in the first interrupt, so I'm gonna take the beginning address plus count. It's gonna give me this one. I'm gonna send it to port B. This number 1. Number 2, after 8 interrupts, I'm gonna increment the count, okay, and then count plus this one is gonna give me this one. After 8 interrupts, okay, count plus this one, you are gonna get this one. So every 8 interrupts, you are gonna every time you increment the count. So count here should help me to know which one I have to display. And then again, similar to what I did in the previous program, once I come to here, I have to come back to here again. I'm gonna show you how it is, okay? Very easy program. Okay, look here, guys. Number 1, so this is what you have to do in order to configure RTI interrupts. This part for 7 segment, just the configuration for 7 segment. You have to use these 2 guys also for RTI interrupts. Now I'm gonna return it to 7F again, which is 131 millisecond. Is that okay? And then this is the main program. I'm just gonna keep looping here, okay? And then this is RTI. So every 100 millisecond, I'm gonna come here, come back. Every 100 millisecond, and come here and come back, okay? See what I did here, guys. So here, every interrupt, as I said, every interrupt, I'm gonna increment RTI count, okay? Because I have to select a number, I have to change the number every 8 interrupts. That's what I said, okay? So here in this part here, look, number 1, I'm gonna increment RTI interrupts. And then I'm gonna compare it to 8. Okay. I'm gonna compare it to 8. If it is not 8, so that means I'm gonna come to here, just leave. This is what this part is gonna do. So here, if it is less than 8 interrupts, I'm gonna come here, guys. If it is 8 interrupts, every 8 interrupts, I'm gonna come to here, okay? Because I told you I have to take action every 1 second, which means 8 interrupts. So if it is less than 8 interrupts, I'm gonna go to the subroutine, just increment the count and compare and then leave. That's it, okay? So every 8 interrupts, what should I do? Number 1, I have to clear RTI count in order to count for another 8. So every 8, I'm gonna display 1 number here. I'm gonna display 1 number. Also, I'm gonna clear RTI count. Is that okay? To count for another 8. Okay. So now that's what I explain now. Now in this part here, we are gonna display 1 digit. Okay. Look how I did it, guys. This is the beginning address here. Okay. And then this is count. And then I'm gonna take byte. I'm gonna take a byte pointed by X plus count plus A, which is count, right? So I'm gonna take 1 byte pointed by X plus count, and then every time I have to increment the count. So now I'm done. So this part here, guys, should be display 1 digit. 1 digit. Okay. Now, I'm gonna display a digit which is which location? The beginning address plus count. Okay. Now look at this part here. Now I'm gonna increment the count for next time. For next time, I'm gonna increment the count. Okay. So that in the beginning count equals 0. So I'm here. When you increment the count, next time you will be here. When you count is 1, count is 2, count is 3. Okay. Once you come to here, you increment count. So count should be 10. So now, if count is 10, so you already displayed this one, okay, which is 9. And you increment the count, so now count is 10. What should I do if count is 10? Return it back to 0 again to repeat, okay? That's what I did here. Increment the count, you can see here, guys, increment the count. Now I'm gonna compare count to 10. If it is less than 10, I'm done. If it's not, so I have to clear count. So simple. This program has to do 3 things. This program has three blocks. This is block number 1. Block number 1, you will check if RTI is 8 interrupts or not. If it is not, I'm going to leave. If it is 8 interrupts, I'm going to come to here. This is part number 1. Part number 2, I have to display a digit, one digit, pointed by count. Pointed by beginning count plus beginning address. Okay. Last part here, I have to update count. This is part number 3. I have to update count. To update count, I'm going to increment the count. And if count is 10, so I'm going to return it to 0 again. Any question, guys? Any question? So this part here, guys, but by doing this part, now the LED is going to count 0 to 9. That's great. So now how also I want to use a push button in order to enable or disable counting, and as which is very easy. All what you have to do, you have to use IRQ so that you enable or disable RTI interrupts. Okay. So the way you can do it here, I'm going to do something little bit different. Okay, I'm going to do here just because I want to teach something different. Okay, what we did before, you can use IRQ in order to enable or disable RTI, and that's what we did before, and that's what you are going to do in today's lab. Okay, again, this is what you should understand. I have different tests, and you can play. You can put this test in the main, or you can put it in IRQ. You can put it somewhere else. Okay, that's what I'm teaching now. What I'm teaching now is that enable or disable RTI. Okay, what if the IRQ is busy in something else? IRQ, I already use it in something else. Okay, you can put it in the main program, and that's what I'm teaching now. Just a different idea. So you can put this task, you can put it in the main program, or you can put it in IRQ. I already taught how can you put it in IRQ. Same thing now, I'm going to teach how can you put it in the main program. Okay. So now I can put here in the main program. Okay. So the way I'm going to do it, if you see here, guys, loop, branch, if set. So if you don't press the button, I'm going to keep looping here. If the button is high, okay, if this pin PH0 is high, I'm going to keep looping here, okay, because you didn't press. Now, when you press the button here, when it is 0, I'm going to come to here. What you are going to do here, similar to what we did before, right? Number 1, you have to toggle the enable bit for RTI, and then this part is just for bouncing, right? Remember, I'm going to tell you something interesting now, okay? Look here, guys. Remember, this is the exact code we put in RTI before, IRQ before. The exact code in IRQ before, okay? But we didn't have this one in IRQ. We didn't have this one, right? We didn't check if it is you pressed or not. Why? Why? Because this is done by the hardware. This is done automatically. I don't need to check. Okay. Once there is a falling edge, come to the pin. Okay. So the interrupt, this subroutine is going to be called automatically. I don't need to check. But in the main program, it's not interrupt. You have to check. Any question, guys? Question, guys? Okay. Now I'm going to move to the next program. I have just maybe 3 more programs. Okay. Before I forget, I told you today. I told you I made it clear. The final exam will cover up to chapter 4. So chapter 5 is not going to be in the final exam. Today I'm going to get in today's lab. I sent the email, but maybe some students haven't read my email yet. So I'm going to give a lecture today in the from 4:30 to 5:50. Okay, just to talk about chapter 5. It's not going to be in the final exam, but if you want to learn, you should attend. Okay. Also, if I don't finish chapter 5, I don't think for sure I'm going to finish it in one lecture. Usually it takes 2 lectures from me. Okay, maybe 2 or 2.5. Anyway, so I'm going to record the video for the rest of chapter 5 so that you can watch it. The good thing, what I'm saying is, guys, the good thing is that by interrupt, this is the most by interrupts you already had the basic stuff. Okay, so you will see when I teach the timer system, you will see nothing new regarding programming, regarding no new concepts. Okay, just we're gonna use still we're gonna use interrupts and so on. Okay, no. Okay, so now I'm gonna teach here the just a couple of program left. So the first program here I'm gonna teach you guys. I wanna make counting, okay, which is from 00 to 99. Okay, so I wanna make counting, but this time I'm not gonna use one digit. I'm gonna use two digits. Okay, so here this program is very important, guys. Listen to me. So now I wanna use two digits. Okay, I wanna count. I wanna count some. Here we assume a sensor is connected to IRQ. You can count number of cars, number of customer, whatever. As I told you guys, so, if you wanna count, for example, here you can put infrared transmitter, infrared receiver. Okay, so there is a light here. No one can see this light. The humans don't see this light. When someone enter a store, right, you can actually generate a pulse here. This pulse can go to IRQ to count, to increment a counter. Is that okay? So that's what we are gonna wanna do right now. What we wanna do, I wanna count certain events. Okay, these events can come coming from a sensor. Okay, it's the same idea as I said. The same idea can be used if you wanna measure the motor speed, because it's exactly the same idea. Where we put here, we put a disk here. This disk should have two holes. That means we should have two interrupts or two pulses every one rotation. So every two interrupts, it means one rotation. Okay. So anyway, so how this program should work? The way you are gonna do it is the following. We are gonna use now we are gonna use RTI and IRQ. So now I'm gonna use RTI in order to take care of time multiplexing, for time multiplexing. Okay, time multiplexing, because I'm gonna display two digits. Remember, guys, if I display only one digit, I don't need time multiplexing, because I'm gonna put one value in port B, only one value. But now I have to put two values in port B. Okay, so I need time multiplexing. So number one, I decided to use RTI to do time multiplexing. Okay, again, this is like design. This is design, how you design your program. If you like, you can put this time multiplexing in the main program, and that's what I taught in chapter 3. Anyway, but in this program, I decided to use RTI to take care of time multiplexing. Okay, what about IRQ? I decided to use IRQ to count, count the number of events. Okay, so here, as I said, every time IRQ is interrupted, okay, you increment a counter, and this counter should be displayed here. Okay. Let me choose a program first before I teach it. Okay. You see now it's number 3. Every time I press the button, I increment it by 1. Because every time I press the button, actually every time I press the button, I trigger IRQ interrupt. IRQ interrupt is gonna increment the count by 1. Okay, that's what we're gonna do now. Just give me 1 second. Yeah, I wanna close this one. Yeah. Yeah. So now, how can we do this program, guys? Look here. I told you, very simple. I told you, IRQ. Okay, I told you guys, IRQ should take care of counting. RTR should take care of the displaying. It should display the number. Okay. So here, in order to count, look, I'm gonna explain for counting, I'm gonna explain two ideas. Okay. Let's start with the idea I already explained before. It's not new. That's what I explained before. Look here, guys. This is IRQ. Okay. Here it should end here. Number one, I'm gonna increment the number. So here I have, this is a counter. So my counter, I call it a number. This is just a variable name. So here I increment number. And then I told you I wanna count from 00 to 99. That's what I wanna do. After 99, I have to go back to 00 again. That's what I wanna do. Here, so here I'm gonna compare. I'm gonna compare to this number to 99. If it is lower, so I'm gonna come to here. If it is not, so if it is not, if it is more than 99, 100, so in this way I have to clear, I have to make it 0 and 0 again. Okay. So the first step here, guys, number one, I have to every time there is one interrupt, every time I press the button, I'm gonna come to here, execute this one every time. Okay. So when I come here, number one, as I said, you are gonna increment the number, and then here this part you have to check. If this number is greater than 99, so that means I have to come to 00 again, this part, okay? And then now, look here, guys, in this part here, okay? Now, my number is between 00 and 99, is that okay? But this number is in binary, because the number is a byte, this is a byte. Okay, it's a binary. So here I need to get, as I explained before, and as you did in test 2, I need to get the 2 digit so that I can display them. And the way you are gonna do it, divide by 10 as we did before. That's what I'm gonna do now. Look here, guys. So I got number, I put 10 in X, and then I'm gonna divide. So when I divide this number by 10, okay, so the remainder has to go to register G, and the quotient has to go to register X. Is that okay? And then, so now I have 2 digits. I have 2 digits. For example, if the number is 37, so now I have 3 and I have 7, right? I think the remainder should be 7. We need, after you divide by 10, this is the remainder, and 3 is the quotient. Is that okay? Now, what I'm gonna do, I'm gonna take 3 and gonna take 7. I'm gonna store it in 2 memory locations. So that RTI is going to take these 2 memory locations, display it on the 7th segment. Okay, that's what I did. So now I'm going to store B, which is the remainder. I'm going to put it in memory location called digits, right? And then I'm going to exchange X with B, with D, okay? And then I'm going to take B, because when I exchange, actually, so here, let's talk about this example, 37. So here what I did in this step, I took 7, I store it in digits. Is that okay? Now, when you exchange, you actually take 3 and put it in G. You take 3 and put it in G, right? And then now, again, as I said before, you remember, when I put it in G, actually it's going to be in B, right? And the A should be 0, because this number should be less than, this number should be less than this number is less than 10, which should be in 1 byte. Okay, anyway. So now I'm going to exchange and then move B to digits plus 1. So the conclusion is, okay, this is what I have to do here. Conclusion is, guys, look here. I'm going to say it again here. So the idea again is, number one, I have to increment the number. Every time there is interrupt, I'm going to increment the number. Number two, here I have to make sure the number should not exceed 99. If it is more than 99, I'm going to clear. If not, I'm going to come here to convert. The purpose of this part is to convert this binary number to 2 digits, and to store the digits in 2 memory location. One is called digits, one is called digits plus 1. Because digits actually is array. So this is the beginning address. This is the beginning address plus 1. So here it's 2 memory locations, okay? So here, that's what I did. So I divided by 10, I got the remainder, I get the quotient, and then I put them in 2 memory location, okay? For example, if your number is 37, so now I have 2 memory location, one has 3, one has 7, okay? This is what IRQ has to do. Why you did it this way? Simply because RTI should take whatever in these two memory locations, display them. So this is how it is. So IRQ should update these two memory locations every time you trigger IRQ interrupt. RTI has to take these two memory locations, display them. Any question, guys? Let me explain now how RTI works. Okay. The way RTI works, guys, is this is a program is here. Again, let me, where is the beginning? Yeah, look here, guys. Similar, I think we had this something like that before, this program before. Look here, guys. So here, the way RTI has to work, very simple. I told you we have two memory location, right? One is called, it's array. So digits and digit plus one, okay? Because digit gives you the address of the first byte. Digit plus one is gonna give you the address of the second byte, okay? So now I have two memory location. That's great. What's gonna happen? RTI, in one interrupt is gonna take one digit, okay? It has to convert it to a code, here, a code, and it has to send this code to port B, and then it has to take one value here to port P to enable one display. This should happen in one interrupt. Next interrupt, I have to take the second number. I have to do the same thing. I have to convert it to a code. I have to send the code to port B. And now I have to take the second one, send it to port P. And then I have to repeat again. Okay? So every interrupt, I'm going to take one digit. I have to convert this digit to code and then send the code to port B. And then I have to enable only one P. Okay? So there are several questions now. Okay? The first question, how I can convert the number here to the 7-segment code? How I can do that? Very simple. All what you have to do, guys, you have to add this number to the beginning address. That's it. So if this number is 0, you are going to get this one. If this number is 1, you are going to get this one. If this number is 2, 9, this one, and so on. So this is the first step. The first step, I have two memory location. This two memory location should be updated by IRQ. In every interrupt, I'm going to work on one of them. Every interrupt, I'm going to work only in one of them. Okay. So what I'm going to do, I'm going to take this number, I'm going to convert it to a code, okay, by adding this number to the beginning address, and then I'm going to get this value, this number one. Number two, okay, what about port P? Very simple. One interrupt, I'm going to take this one. Next interrupt, I'm going to take this one. One interrupt, I'm going to take this one. Next interrupt, I'm going to take this one. Okay. How can you do that? That's why here I'm using count. So all what I'm going to do, guys, is because one digit, you remember this one should enable one 7-segment, right? So here, 0 plus the beginning address is going to give you this one. And then I'm going to increment the count, right? So now count is 1, okay? And now next interrupt, 1 plus the beginning address is going to give me this one. Is that okay? And then I have to clear so that I'm going to come back to here, okay? So that's what you will see now. So let's see the code of RTI. This is RTI, guys, here. Number one, I have to use this one for sure. This one to clear the interrupt flag bit. This is number one. Number two, as I told you, here, the beginning address, I'm going to put it in X. This is the beginning address. I'm going to get one number, digit. So digit, I told you, I'm going to put it in Y, okay? And then I'm going to add, I'm going to get count because what I'm going to do, I have two variables, right? I have two variables. One is called digits, right? It's array. The second one should be digits plus 1. One interrupt, I have to take this one. Next interrupt, I have to take this one. Next interrupt, this one. Next interrupt, this one, and so on. So every interrupt, I have to take one of them. How? Count should help me because count is 0. So 0 plus digit, I'm here. Then I'm going to increment the count. So next time I'm going to come to here, okay? So you can see here, guys, I'm going to put count to B, and then I'm going to add, look here what I did. Look at this 3. And then I'm going to add Y, which is a digit plus count. So it's going to be digit plus 0 or digit plus 1. Because count all the time, count should be in one interrupt 0, next interrupt 1. Okay, next interrupt 0, next interrupt 1, next interrupt 0, next interrupt 1. So that one time I take this one time I take this one, next time I take this one, next time I take this one. Okay, and the same thing here, here also, here in these two. One interrupt, I'm going to take this 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 one, because every interrupt I have to enable 1 7 segment. Okay, so what I did here, guys, as you see, I got digit plus 0 or 1 just to take which digit of them. Okay, now I have to the digit. I have a pointer to the digit, which is y. So y is the pointer, and then I'm gonna read the number. I put it in A. So now A should have the number. The number I have to display, number 3, 7, whatever. Okay. Now I have to convert this number to a code, and that's easy. That's what I told you. All what I have to do, I have to add the number plus this one. Okay. So if the number is 0, I'm gonna take this one. If it is 1, I'm gonna take this one, and so on. That's what I did here. If you look here, guys. Here. Because X is pointing at the first location, and then I'm gonna add A. What is A? A should be the number I want to display. So now I convert it to 7 segment code, and then I have to send to B. So now I'm done with B. Now I have to look at P. I have to take care of P. And P, as I told you guys, very easy. One interrupt, I have to do this one, another interrupt here. Because if in every interrupt I have to enable, in every interrupt I have to enable one 7 segment. Okay. Okay, so that's what I'm gonna do now. So here, this part here. So here, look here, guys. So what I'm gonna do now, as I said here. So here is gonna be this is the beginning address, okay, and then this is count. All what I have to do, I'm gonna take the beginning address plus count and send it to port P, right? So here I'm gonna take the beginning address. Sorry. Here, I'm gonna take the beginning address plus 0, plus 1, plus 0, plus 1. Every interrupt, because count is 0, 1, 0, 1. Okay. And then after that, I'm gonna increment count. Okay. And then I have to check if count is 2, I have to clear it again. Because count has to work this way. In one interrupt, count is 0. Next interrupt count is 1. Next interrupt count is 0. Next interrupt, it has to be this way. Why? So that in one interrupt, because I'm gonna add the beginning address here plus count. So by this way, count plus 0, I'm gonna take this one. Count plus 1, I'm gonna take this one. So one interrupt, I'm gonna enable one display. Next interrupt, I have to enable the next one. Okay. Any question, guys? So let me quickly explain what I did here. What I did here, guys, is for sure, this idea is just for 2 displays. I think you can extend this program to make it for 4 displays. It's not difficult. You can easily extend it. Okay. All what you have to do, if it is 4 displays, now count should be 0, 1, or 2, or 3, because now I should have 4 values here. I should have this one should have 4 values, right? Because I'm going to use 4 displays. Also, this one should have 4 values. Every interrupt, I have to take 1 value. Okay. Anyway, so here what I did here in our program, guys, simply in the first part here. Okay. I took a byte here. This is, I have 2 numbers, right? So here I took one number. So that one interrupt, I'm going to take 1 number. Next interrupt, I'm going to take the second number. Okay. And then I'm going to add this number to display tab. Okay. In order to get the code and then put the code on port B. Okay. Here, I have to enable one 7 segment. So the way I'm going to do it is this array should have the code to enable 7 segment. So here I'm going to add count plus X. So actually what you are doing is going to be X plus 0 in one time, X plus 1 in next time, and then X plus 0, okay? So that you take, every time you take 1 of 2 values, okay? Finally, I'm going to increment the count, but I have to make sure count always should be 0 and then 1, 0 and then 1. So if it is 2, if you increment it and it is 2, if it is 2, I have to clear. Okay. Any question, guys? Questions? Any questions? Okay. So now I finish this program. Okay. But what I want to do is now, what I want to do, I want to just explain another idea. Just again, whatever you like is okay to me. Okay. But again, I'm as an instructor, you should learn different techniques, different ideas for programming, right? Whatever you like is okay, but it's very useful to learn different ways. Okay. So I told you this is how I explained IRQ, guys. Okay. This is how I explained RQ. The idea is that every time IRQ is interrupted, you increment a binary number, and then you have to convert this binary to digital by dividing by 10, and you have to store 2 digits in two memory location. And RTI has to use these 2 memory location. So that's what I explained here. Okay. Now I can do this increment in a different way. Okay. So the way I'm going to do it is somehow different. Okay. From this one. The idea is that I'm going to have 2 memory location, guys. Look here how I'm going to do it. Okay. I'm going to have 2 memory location bytes. This is a byte. This is a byte. But it's a byte. It can take a value from 0 to 255. 0 to 255. But I'm not going to do that. I'm not going to, because every byte here is going to be a number, a decimal number. Okay. That means also as a byte, it can take a value from 0 to 255. No, I'm going to force this one to be a number from 0 to 9. Also, I'm going to force this one to be a 0 to 9. Is that okay? So that in this case, I don't need to divide by 10 to convert, because I'm gonna keep the format. I'm gonna keep the format of this number in decimal. In decimal. How you are gonna do it? I'm gonna tell you how. Okay. The way I'm gonna tell you what is the trade-off. There is a trade-off here. The trade-off here is the increment is easy. You just want an instruction to increment. Increment is easy, but you need a code to convert. Now, the way I'm gonna do it right now, I don't need a code to convert, but increment is gonna be somehow more. I have to write more instruction to do increment. So the way I'm gonna do increment is that I'm gonna for example, I'm gonna increment this one. Okay, sorry, this is less significant. So I'm gonna start from here. Okay, now there is event. So I'm gonna increment this one. So now I have 1 and I have 0. Good, which is good. So then increment this one, 2, 3 until 9. Okay. Now so now I have number 9. You can display number 9. Okay. Now when you increment 9, you is gonna have 10 here. Is that okay? Okay. What I'm gonna do is, listen to me, because this is a byte. This byte can have a number from 0 to 255. Okay. So now I will check if this one is 10. If this one is 10, so I'm gonna make it 0, and I'm gonna increment the next one. You got what I'm saying? So it's somehow interesting idea. So I'm gonna use 2 bytes. Every byte is gonna store a decimal number. Decimal number, that means it's between 0 and 9. And when I do increment, I have to make sure the format of the number is always decimal, so that I don't need to divide by 10. You got what I'm saying? The way you have to do it is, you have to increment the least significant byte first. So you have to increment this number first. Okay? It's similar to what we do in counting, right? And now, if this one is 9, so 0, 9. What should be after 0, 9? It shouldn't be 10, 0. It shouldn't be something like that. It has to be 0, and I'm going to put 1 here. I'm going to do it this way. Okay, guys? Same thing if it is 19. Okay? So I'm going to make this 0 and increment the next one. I'm going to choose a code for this part here. The code, you can see the code here, guys. So what I'm gonna do here, guys, I'm gonna take the first number. Okay, I'm gonna increment the first number, as you see here. Again, I have two numbers. One number. So here, digits is an array. This array should have 2 numbers. Okay, so when I use digit, actually you are gonna use the first number here. Anyway, so here I'm gonna increment the first number. Now look here, I'm gonna check if this number, I'm going to check if it is 10. If it is less than 10, Okay, so what I did, I took this number, I incremented it, and it is less than 10. What should I do? Nothing. I'm done. I'm done. So I have to come to here. If it is less than 10. Make sense? If it is 7 or whatever, less than 10, just leave. I'm done. Okay. Now, if this number is 10, what should I do? I have to clear this one. I have to increment the next one. That's exactly what I did. I have to clear first digit, and then I have to increment the next digit. You see what I did? 1 comma x. 1 comma x should be next digit, right? So I have to increment the next one. But also there is a concern here. What you, if after, for example, after 99, okay? If you increment this one, right? If you increment this one is going to be 0, and it's going to go increment the other one. The other one is going to be 10. Also, the other one should not be allowed to be 10. That's why I have to check here. When I check here, I'm going to compare it to 10. If it is not 10, leave. If it is 10, I have to clear it. As you see here, I have to clear both of them. Any question, guys? You get the idea? So let me summarize what I said. I explained two ideas for counting the events in IRQ. One idea is that my number is going to be in binary, and this number can take number from 0 to 99 in binary, right? And then I have to convert here binary to decimal to get 2 digits, right? This is one idea. Another idea, no, I'm going to use 2 digits. I'm going to keep the format of the byte and byte, but I'm going to keep the format to be in decimal. So that means, for example, if there's 1 7, it's going to be, when you increment, I'm going to make it 1 8. When you increment, I'm going to make it 1 9. When increment, I'm not going to make it 1 10, right? I'm going to make it here 0 20. So here, the way I'm going to increment is I'm going to keep the format in decimal, in decimal. Okay. Any question? Okay. Let's see the next program. The next program is similar to this program. The only difference is that, look here, guys. In this program, who's gonna increment here? Here, write a program to count from 0 to 99, and increment the count every 1 second using RTI, and IRQ is gonna stop counting or resume counting. Okay, so here this program is exactly similar to the previous program. The only difference is that in the previous program, counting is done by IRQ because I want to count some events. So here I have a pin. This pin is connected to like a sensor, and I want to count some external events, right? But now I want to count from 0 0. I want to count from here 0 0 1 2 3, but using RTI. Is that okay? So it's going to be like counter every 1 second. Let me choose a video first before I talk about the program. But programming wise, it's very easy. It is similar to what I did before, but I'm going to write the code. The code I wrote in IRQ, I'm going to write in RTI because counting should be done by RTI this time. Okay. So let me choose a video first. This is counting, yeah, counting this one. Look here, guys, it's counting every 1 second, 30, RTI, because counting is done by RTI. It is not done by IRQ, right? So see, 37, 38, 39, and then I have to press the button. When I press the button, I'm gonna disable RTI. I press again, enable RTI. That okay? I wanna do something like that, okay? Programming wise, nothing new. It is similar. It is similar to what I taught, but the only thing I'm gonna transfer the code, the counting code that was in IRQ. I'm gonna transfer it to RTI. Okay. Just give me 1 second. Again, this program is only for 2 displays. It's very easy if you understand this program. It's very easy to extend this program to 3 displays or 4 displays. Okay. So this is the program is here, guys. Let me change the color. Okay, so now what I need, guys, is that this is a very interesting program because now I have 3 tasks. Listen to me, guys. Now I have 3 tasks. Why it is 3? The first task, I have to increment. I have to increment the number every 1 second. Every 1 second. And RTI is going to take care of this. So RTI is going to take care of this increment. Number 2, I have to use IRQ to enable or disable RTI interrupts. Is that okay? Number 3, what is left? Number 3, time multiplexing, because I'm using more than one display, so I need time multiplexing. Okay, guys. So this program needs 3 tasks. Okay. So I cannot do time multiplexing and the increment at the same time in RTI. Okay. So we have 3 tasks. So time multiplexing, I'm gonna put it in the main program. And that's what I told you before, guys. I told you now we have 3. Listen to me. Now my program can be written in 3 places. Apart in 1 task in to IRQ, 1 task in RTI, 1 task in the main program. And someone can tell me, but you took only 2 interrupts for us. That's okay. But in the timer system, we have 8 more interrupts. 8 more interrupts. That means your program can have many tasks. You can put 1 task in every interrupt source, right? That's how can you make big programs. Okay, anyway. So if you look here, if you see here, let me, oh, sorry. Okay, so this is the main program, guys. I told you in the main program, I'm gonna do time multiplexing. And this is exactly the same code. This is the same code exactly I have just explained right now. Okay, you remember this code? I have just explained right now. When you have count, right? And this count should have a value from 0 to 1, right? And then I have 2 digits, exactly the same. This is the same program I taught it here, because here, yeah, it's the same. So I'm gonna take this task here, guys. This task was used for time multiplexing. Here I used RTI for time multiplexing. So I'm gonna take this code from here, I'm gonna put it in the main program. Okay, that's exactly what I did here. So this code similar, exactly same thing. I'm gonna put in the main program because the main program is gonna take care of time multiplexing. Okay, so if I'm not gonna teach it again because it's exactly, I just took it from RTI, I put it in the main program. Any questions? Okay, now let's look at RTI. Okay, RTI should increment. All what RTI has to do, okay, all what RTI has to do is exactly what IRQ did here. Exactly. What IRQ did here is every time I press a button, I have to increment a number, okay? So I can use this program or I can use the other program I taught here, the other idea, okay? So here, IRQ should increment a counter, right? So, but now, increment should be done by RTI because I need to increment every 1 second, right? And that's what I did here. So look what I did here, guys. Here, again, every interrupt, here I have to see if it is 8 interrupts or not. This is what usually we do. If it is less than 8 interrupts, I'm gonna leave. Less than 8 interrupts. If it is 8 interrupts, so here in this part, I have to increment. And after I increment, I have to update digits and digits plus 1. Okay, this is exactly what I did right now in IRQ. I'm gonna move it to RTI because this increment, I wanna do it every 1 second by RTI. This is exactly the same code I have just explained here before. Okay, guys? So this is, and now IRQ here, IRQ just, I'm gonna write a code for IRQ to enable or disable RTI interrupts. Okay, interesting, guys. Any question? So now I have 3 different tasks, and now I'm gonna use the main program, I'm gonna use RTI, I'm gonna also use IRQ. Okay, and as I told you here, I explained for 2 displays. It's very easy to extend this program for 4 displays, very easy, right? So as I said, count can take 0, 1, 2, and 3. This is number 1 you have to do. Number 2, what you have to do is here you have to add two more displays, enable for displays. Okay, here this one has to be 4. Okay, also when you increment, you have to make sure you are, or when you convert binary to decimal, you have to make sure you have to get 4 digits instead of 2. Anyway, you can modify it. Any question, guys? Okay, so this is the last program in this chapter. It's also very interesting program, and it is in C language. So I want to teach this program, and that should be the end of today's lecture. Okay, and again, I'm gonna give a lecture at 4:30. It's not gonna be in the final exam, but just I think it's important to learn. Okay, especially it's extension to what we did. It's not something new. Just we are gonna use interrupters and things like that. Okay. So I'm going to record it. Even if, I don't think we're going to finish chapter 5 today. So I'm going to give a lecture. I'm going to record it, and then I'm going to record another lecture. I'm going to put them online so that you can watch them to get idea about what is timer. You may need it in the future. Okay, but at least we finish the basic stuff, the most important stuff. Okay, anyway. So this is what we want to do here. What we want to do here is something very interesting. I want to make like traffic signal. Okay. So here I assume we have 2 streets, like Willow Street and Spring Street. Okay. So you have 2 streets intersection here. Okay. And either this way the cars has to drive this way, or the car have to drive this way, right? So one of them should be on at a time for sure, right? So here I assume this is I'm gonna use 6 LEDs, as you see here, 6 LEDs. The first LED, it means green for Spring Street, yellow for Spring Street, red for Spring Street, and then green, yellow, red. So the other, so I'm going to use 6 LEDs, 3 for the three color for one street, and 3 for 3 color for the other street. Okay, how it should work? I'm going to tell you how it should work. Okay, should we have states, different states? In the first state, in state 0. So Willow has to be green. And if Willow is green, that means this one should be on. This one should be on. Okay. For sure, everyone else should be off. Okay. And this is for Willow. If this one is green, so this one has to be red. Otherwise, you are going to make accident, right? So if one is green, the other one should be red. Okay. So this is one state, green and red. And this state has to stay for 5 seconds, right? So once I am done, after 5 seconds, I'm going to move to next state, which is state number 1. In state number 1, so now after green, what should come after green? Should be yellow, right? So this one has to be yellow. Okay, that's what I did, yellow and red. And this should continue for 1 second, right? After 1 second, I'm going to move to the next state. The next state is red and red, both are red. And this has to continue only for 1 second. Okay. After this state, I'm going to move to the next state, which is green here, green, right? And red here, right? And so on. And this has to stay for 5 seconds. Okay, guys. This is traffic light. Okay. So the traffic light here, as you see, guys, we have a state. So this state, green, red, has to stay for 5 seconds. Yellow, red, 1 second, and so on. And so once I finish all the states, I have to repeat again. I have to come back to repeat again. Okay. How can I program something like that? Okay. I'm going to tell you how. I'm going to explain it. So the main idea is that, guys, I'm going to create 2 arrays, as you see here. This is C language. So I'm going to create 2 arrays. One array, okay, for what number I have to put in the LEDs. Okay. So this is for state 0, state 1, state 2, state 3, and state 6, and so on. Okay. We have 6 states, right? No, sorry, from 0 to 5. Okay. So from 0 to 5. Same thing here for delays. For how long? So here, if you see here, for example, in 0, I told you it has to be, this one has to be red, this one has to be green, right? So here, this is the value. So if I'm in state 0, this is the value I have to put on the LEDs. If I'm in state 1, this is the value I have to put in the LEDs, and so on. Okay. So this is one thing. The other thing, this state has to stay for 5 seconds. How I can do that 5 seconds? I'm gonna store the corresponding. You remember when I told you 8 interrupts? Because 8 interrupts should make 1 second, right? But now, if I'm gonna use 10 milliseconds, right? That means if you want to make 5 seconds here, that means I should count for 488 interrupts. So I'm gonna make array for this one, okay? So here, if I'm in state 0, I should not move to state 1 until 488 interrupts, because 488 interrupts means 5 seconds, because I want this state to stay for 5 seconds. Is that okay? And then if you are in state 1, okay, so I have to count for 98 interrupts. 98 here, if you multiply it by 10, that means 1 second, and so on. So the conclusion is, this is the conclusion. I created two arrays. Every array should have one element for every state. So if I'm in state 0, I have to take this value. I have to send this value to the LEDs if I'm in state 0, okay? And also I have to take this value, and this should be the number of interrupts I have to count before I move to the next state, right? Any question? I'm gonna show you how it works right now, okay? So now, this is how it works, guys. Look here, I used a variable. This variable is called, and it has to be global variable, because I'm gonna use it here in RTI interrupt subroutine. This variable is called IX. So IX should be tell me the state. So IX should state 0, state 1, 2, until 5. After 5, I have to go back to state 0. So IX should be tell me which state. In the very beginning, we are state 0. So if you see here, guys, if you are in state 0, I'm gonna take the element number 0 here. I'm gonna send to the LEDs. So I'm gonna take here IX. In the very beginning, IX equal to 0. So I'm gonna take this one. I'm gonna send to the LEDs. Is that okay? And I'm gonna take this one, put it in a variable. Look here. I'm gonna take this one here. I'm gonna put it in a variable called D time. Okay, so that this is the most important thing. Okay, guys. So that look what's gonna happen after that. Every interrupt, I'm gonna decrement D time. And if D time is not 0, I'm not gonna do anything. I'm gonna because this is, if it is 0, let me make it better. Look here. This is if it is 0. Okay. Okay. So here D time. Okay. This D time should have how many interrupts I have to count before I come here and I move to the next one. Is that okay? In the very beginning, as I told you, I'm gonna, it's 488. So here I'm gonna put 488 in this one, so that I have to count 488 interrupts before I come inside here. When I come inside here, that means I have to move from one state to another. And that's, so here, because in every time I have to increment X, as you see, increment IX, okay? And if IX equal number of states, which is, if it is equal 6, I think it has to be number 6, sorry. If it, okay, guys, so here, this is number 6, okay? So what I'm saying is that, I'm done, just 1 second, okay? So here, what I'm saying is that, guys, okay, here should be number 6 is here, okay? If it is equal to number 6, I have to make it 0 again, right? Because once I'm done with 5, I increment in it, it's now 6. So I have to make it 0 again, okay? So this is the main idea, guys. What's happened, quickly, what's gonna happen, we have a variable called IX, right? IX in the big should tell me which state, okay? And if it is state 0, I'm gonna take this part, send it to port B. I'm gonna take this one to send it to a variable called D time, right? And this variable, as you see here, is gonna be decremented in every interrupt, okay? This variable is gonna determine how many interrupts I have to wait until I get inside here, okay? Once I come inside here, so now I have to move from one state to another. So I'm gonna take the new value incremented, pointed by IX, right? I'm gonna put it in the port B, and then I have to take delay, put it in D time, and then I have to increment IX for next time. Is that okay? So IX is here. Once I take this value, I increment ix. Once I take this value, I increment ix. Once I take this value, I increment ix. Once ix is 6, I'm gonna move it to 0 again. Any question, guys? So here, ix is gonna go through this array. Every state is gonna take one value from here, and it's gonna take the corresponding value here, the corresponding value. This value has to go to d time. D time is gonna determine how many interrupts should happen before I move to the next state, right? Any questions? Just in 1 second, I can show the video. Just in 1 second. Very interesting program, very easy. You can see now, look at the video here, right? I think it is, what is this now? So I think it's red and green. Yeah, so the first yeah, now BB4 is the yellow for one street, and then red and red, and now green and red, one street. Remember, 3 LEDs for one street, 3 LEDs for one street. So this one is gonna continue for 5 seconds because this one street is green, and now with this street for 1 second it is yellow, and then both are red, and now one street is red, the other one is green, right, and so on. Okay, I think that's enough for today. And okay, any question, guys? So see you for 30. Any question? Okay, bye.